Hello, everyone.
Hello. Welcome to our talk. This is Baby Got Backups, or also known as How to Leverage Your CF Blobstore Provider to Improve Your Backup Experience. I can see you're all excited. It's now over here. It's not going.
Imagine if we hadn't tested.
We had tested it,
Yeah, no?
and then I messed with it.
Isn't it downward?
Oh, there we go. All right, so on that wonderful awkward note, I'm Sarah Connor. I am an engineering manager at Pivotal and an engineer on the platform recovery team.
I am Emmanouil Kiagias. I'm a software engineer at platform recovery team. We work together. So in our today's talk, let's look at a bit like the agenda. How do it look like? We're gonna go through a bunch of stuff. We're gonna talk about why backups are important. We're gonna talk how the world looks like today. Then we're gonna see what's the aspects of backup that we care about. And then we're gonna see how different Blobstores backup strategies affect your whole backup experience, and mainly internal versus external. And then we're gonna visit them one by one. Then the big question, do I really need to back up everything after all? We're going to do a recap and talk a little bit about the future, depending on time. So let's get this out of the picture. We know that backups are important, right? So that's why we're here for. Let's look how the world looks like today. So you got BOSH, and then BOSH deploys your Cloud Foundry, and then you have BOSH Backup and Restore, which really backs up both of them. But today, mainly, we're going to talk about like Cloud Foundry, which has like many components. But if you think about it, it always goes down into two stuff, like a database and a Blobstore. That's where the state is. That's what we really want to back up. And we're going to focus mainly on the Blobstore. The things we care about here, like the DB dumps usually contain information like users, org spaces, bindings, credentials, and this stuff don't really go very big, so we don't really have trouble backing that up, but we have problems backing up the Blobstore, which has all the application artifacts, which are like source code, compiled artifacts, build packs, everything, and that like grows big, and that's what's causing problems in our experience. Now we're going to see the aspects of the backup.
Sure. So imagine the scenario. You have your backups. You want them to be very frequent. You want very minimal downtime. You want your size of backups to be not too great, because none of us wants to eat away storage costs based off of a giant backup. And you want that recovery period of time to be very, very small. So we've got our BOSH director. We've managed to deploy our CF. And we started creating orgs and spaces, and our application developers are now up and running. They can start deploying, their hot dog vendor app. You've got some internal networking apps in another org. But then everything goes on fire, and that's where we start to panic. That's where we're really in a situation where everything's not so great, and you'd like no one to talk to you or to interrupt you, or just, don't talk to me until this is back up and running. So we're going to talk about backup frequency. If you had a backup and it was taken, last week, maybe the only thing that you lost was your hot dog vendor website. And that's great. You can just repush that one app and you're up and running again. If maybe it was slightly older backup, maybe you've lost your entire orgs and spaces, maybe you have to recreate some users and you take more time to get back up and running. Maybe it's an even older backup. Maybe you only backed up your BOSH director and you are probably in not a good situation. You have to get everything back up. So the more frequent your backups, the less data you are losing, the less time it takes to get back up and running. So let's talk about backup downtime. So when we talk about BBR, it stands for BOSH Backup and Restore. It's a CLI originally designed to back up the BOSH director, and it now is able to back up any sort of BOSH deployment. It has 4 stages. One is the lock phase. This is each component tells the BBR CLI what it needs to lock up and in what order. So this could be like UAA needs to lock up before CRUD, that sort of thing. At that point, we have a backup, which is the actual physical copying of files, DB dumps, that sort of thing. Then we unlock, and then we need to drain the backup artifacts off to your jump box. So what that looks like is we have a jump box. You are running BBR deployment CF backup from that jump box. It communicates to CF. CF locks all of its APIs and then starts to create the backup artifact locally within that VM. And then at that point, it unlocks its CF API and then starts to drain to the jump box. The more things in your CF deployment that you are backing up, the longer this backup will take. So just to recap, the things that we are really aiming for when we talk about a really good backup strategy is minimal data loss, minimal storage costs related to those backup artifacts, and then also minimal downtime. And the very good one, which is the low recovery time objective, which is your RTO, we really don't want to have to take that recovery time to take, hours, days, weeks. We want to be up and running within, matters of minutes. So I want my backups often, I want my backups fast, I want my backups small, and I want to recover fast.
Thank you, Sarah. So now we have a distinction in our heads between the downtime and the overall backup time. Like the downtime is only when the platform is locked, and then the backup time is the end-to-end until you get the backup artifact down. Now let's see, if we have an internal Blobstore, the Blobstore lives inside this big cloud, which is your foundation. So if something goes wrong with this thing here and catches fire, then you lose all of your blobs. So it's very critical to get things out of there. So in our case, we need to get it out if it's an internal Blobstore like a WebDAV. And if things catch on fire, your deployment, you still have your blobs outside there and you're covered. Now, so the internal Blobstore strategy is pretty straightforward. You just copy all the blobs and get it out of the deployment. It's just as simple as that. And the Blobstore artifact looks something like that. You have a number of blobs and you have some checksum for them. So the local copy of the blobs is fast because we just create some hard links like in the local copy. The thing that takes a lot of time is to drain all these things outside of the deployment. You have 1 terabyte of Blobstore, you need to download the terabyte to your Jumpbox or wherever you run the backup from. So that ends up having a very big artifact because it contains all of the blobs. And so its aspects, it has a short down time because it's just the hard links, so good here, but the long backup time because you need to get everything out of there. You need to get everything out of there, and you need a big backup artifact. You end up having all of your Blobstore local. Now, in the situation where we have our Blobstore in a storage provider, the picture looks like that. One might say, if my Blobstore is outside and things catch on fire, then I still have my Blobstore out. It's partially true. Then what happens if you just manually delete a space? Then you're screwed because you don't have your blobs again. So we really lose data even if we have them outside of your foundation. So what do we do there? We really need to back up external Blobstores. We come with these flavors, right? So Cloud Foundry can be configured with an S3, S3 compatible Blobstores, Azure, and GCS. And let's thinking about how do we back it up. Can the storage provider give us any smarter ways to think of backing up, of just like copying the blobs? And the answer is sure, most of the times, and we're going to explore one by one. Let's start with S3. So in a regular S3 setup, you're going to have a bucket, and inside the bucket in time 1, you just have 3 apps, or like 3 blobs, A, B, and C. And then imagine in time 2 greater than 1, you just delete an app or just change an A, that leaves you end up with B and C. S3 now has versioning. Let's see how the versioning feature of S3 looks like. In an S3 with versioning, you end up having a bucket, but now this time your blobs have also version IDs. You have like version 1, 2, and 3, which are like unique IDs for these blobs. So in infinite time 2, you just change A or delete A, for instance. Instead of having that removed, you essentially have the old A stay around, and then a new version of A gets created. So in that case, our backup artifact consists of just taking a record of these things. So the backup strategy looks like that. List all the latest versions of the blobs, record these versions, and then we are done. And the backup artifact is as simple as that. You have a list of keys and then the version IDs. So it's fairly straightforward. So the backup is fast because it's as slow as it takes to list all of the blobs. That is, then the artifact is small because it's just like a text file containing just the version IDs, and the backup is, overall great performance. The question now is, if I have things staying around and I delete them and they stay behind, won't like my Blobstore always like getting bigger and bigger? And the question is yes, that's why we need to do some manual cleanup. And S3 for that has a thing called lifecycle policy. With a lifecycle policy, you can think of it as a set of rules where you define that group of objects should do that after that amount of time, for instance. In our example, we have, if a blob is marked as deleted for 7 days, let's say, please clean it up. And that assumes that you take a backup every 7 days. Yeah. And its aspects, short downtime, short backup time, and small backup artifact. It's really very great if you have S3 with versioning. The problem is that is every S3 provider, though, supports the versioning feature? Because it's not like by default there. And unfortunately, no. So we need to think of different ways of backing up the S3 compatible APIs that do not support versioning. So in that case, in the unversion, we have a bucket. So imagine you have the blobs. If you don't want to lose them, you need to have a second bucket and just copy them over. It's as simple as that. So the backup strategy of that, we have, in terms of vocabulary, we call this the backup bucket, and we name this a live bucket. So the live bucket is the one that your foundation is using, and the backup one is the one you store your blobs in. So this is what the backup really consists of, a backup bucket and a reference to these blobs in there. So the strategy is just copy all the things from live to backup, as simple as that. The question is, can we improve this? If we're using the same backup bucket over and over for the same foundation or even for different foundations, what can we do? Yes, incremental backups. And in that case, incremental backups looks like that. Imagine that this is an old backup of yours, and this is your foundation on a different point in time. So we see in this picture that we have A and C in our previous backup, and only D is a new thing that we don't know about. So imagine while the platform is down, and the downtime that we care about, we just copy over just D across the live bucket and the backup. Then we unlock the platform so we don't have any downtime. And we can take our time and do some local copying inside the backup and have a full new backup. So the strategy looks a little bit like that. During the lock time, you just list the blobs from both the live and the bucket. You calculate the delta, where the delta is copy the new blobs from the live to backup. I unlock my platform because I don't want downtime, and then I copy the same blobs within the same backup bucket. And this is how we do incremental. And the blobs, again, look like that. Has like a reference for the directory in the backup bucket and a list of your blobs. So the first backup is slow, as you can imagine, because like the first time you take a backup, your backup bucket is empty. So it's going to be slow. But the bigger, and then future backups should be faster, and that's assuming that between the times you take backups on your Blobstore hasn't really changed that much. So if you push only a couple of apps between the last backup, the new backup should be fairly fast. The artifact is small because you only keep records to the backup bucket, but you don't avoid the storage cost at this point because you need a lot of space for the like the blobs inside the backup bucket. But the good thing about this approach, it works in every S3 compatible implementation. We don't need to worry about the vendor. Yeah, this works. So the backup aspects, like the variable downtime, the first time is slow, next might be fast, we don't really know, that's why it's variable. Big backup time though, so the end-to-end experience, you need to take a full copy of your Blobstore somewhere, maybe inside the provider, so that's slow by nature, because you need, yeah. And then the small backup artifact, bad, you have all the blobs duplicating the storage provider, so it's not that fun either. Let's see about Azure. Right. Does Azure have any nice features we can use? Sure does it has. Soft deletes. What are soft deletes? You can think about it. If I delete the blob, it's just marked as deleted. That's why it's soft deleted. So every object, very similar to the S3 version ID we saw in the previous slides, we have an e-tag ID, and we just use that. So the approach is almost identical to the S3 versioning. So list all the e-tags of the blobs, record the e-tag IDs, and that's it. And this is your backup artifact as well. And similarly to the S3 versioning, with backup is fast, just the time to list the e-tags. The artifact is small, the records, always backup performance. And we don't have multiple providers, so if you have Azure, Azure always works with soft deletes. So it's great. Again, we need to have a lifecycle policy, although in Azure's vocabulary called lifecycle management policy, which is the same if a blob is marked as deleted for 7 days cleaned up, or whatever your X days you want to retain your backups for, really up to the operators to configure that, just to make sure you don't balloon your Blobstore. And we have short downtime, short backup time, small backup artifact. This is also a great candidate. So Azure with soft deletes and S3 with versioning. GCS. GCS has versioning, but we cannot use it. The reason we cannot use it is that it doesn't have a good lifecycle commands. So for instance, you cannot tell to GCS if that blob is deleted for 10 days, please remove it. It only has things related to age. If it's 10 days old, remove it. And we don't want to play with age, we want to play with the deleted ones. So unfortunately, it will always grow bigger if you start using that. Or we have people going manually deleting stuff we want to avoid. So we treat it as an inversion Blobstore, although it has features. So we have to copy everything from the live to the backup. And that's sad because it has features, but we cannot really utilize them. The backup looks like that. And the backup is slow. Unfortunately, the artifact is small, but you keep things around as well. And If in some time in the future GCS provides some kind of lifecycle policy, maybe we can switch to versioning or just switch incremental, because for now it's just the naive implementation, copy everything. We haven't done incremental for GCS yet. So long downtime, every backup is slow, long backup time, full copy of the Blobstore, and the backup artifact is small, but you have the storage costs. And that should be all for the external Blobstores.
Great, thank you, Emmanouil. So we talked about how different external Blobstores and the internal Blobstore can kind of be used to have different backup performances. And one of the things that we also asked ourselves, and is a new feature of CF deployment, is can we selectively back up the Blobstore? Do we need everything in that Blobstore? So we've been calling it selective backups. And this is essentially going through the Blobstore and only selectively backing up certain aspects of it. So the aspects of a CF Blobstore, we have the build packs, which is basically everything that your app needs to run. So that'll be like the Java runtime environment or Ruby or whatever you need. You have your packages, which is the source code of your app. And you have droplets, which is the stage version of your app. So that'll be compiled versions of your app. So in an example that we drew from some of our customers, and this is a customer with a lot of Java applications, the majority of their Blobstore, about 70 to 80%, was actually entirely their droplets, so the compiled versions of their apps. The next big killer was the packages, and the build packs are actually quite minimal, only about 0 to 5% of the Blobstore. So what were our motivations? We were trying to reduce our backup downtime, and we were also trying to reduce our backup size, which impacts both the storage costs and how much downtime you incur. The only problem is that you then end up trading it off for RTO, so your recovery time objective. So if you have a very large, full Blobstore backup, you incur higher downtime and higher storage costs, but your recovery time is very low. On the other hand, if you reduce the size of your backup to a selective backup, then you end up trading it off for more RTO. So in our restore workflow, we have a disaster scenario, we have a full backup, and the process for recovery is just simply running BBR deployment restore, wait some time, and you're up and running and you're happy again. In the other situation where you have a selective backup, and there's two flavors. In this one, it is to exclude droplets. At that point, you have to run a BBR deployment restore. You wait a bit of time. And then at that point, you have to get all of your app developers to restage their app. So you have to do a CF restage of your app. So that takes an additional cost to your recovery time. But at that point, you're up and running again. If you're even more lean and you only selectively back up just your build packs, then you end up doing your restore workflow, and then you have to get every single app developer to re-push their apps. And pushing means that they have to restage it, and then it gets uploaded again. And at that point, obviously, it has the highest recovery time of all. Great.
I think we have plenty of time for summary.
Excellent. All right. We're really worried about time. We have time. So in summary, the things that we back up, the things we covered specifically in this talk was about CF deployment, but we also, the same tool could be used for BOSH, for PKS, and other things. We specifically use the BBR CLI, which is open source, and there's also an SDK that you can deploy with CF, which will come packaged with other things as well, scripts to back up your deployments and your Blobstores. And we talked about things that we desire out of a backup. Small backups, frequent backups, fast recovery time, and very low downtime. When we talk about the Blobstores, we talked about the downtime, and specifically we have fairly good downtime for internal. The only one that was quite bad in terms of downtime was the GCS, and the S3 incremental is not as optimal as it could be. In terms of the time it actually takes to take the physical backup, so not just the downtime itself, internal takes quite a long time, even though it's not during the downtime. And the same thing with S3 incremental, it's just that we've abstracted it away from the lock period. In terms of artifact management, internal has the highest one because you have to do all of that yourself. You are determining, okay, how is the lifecycle management of my artifacts going to happen? Am I going to be SCPing things over from jump box to jump box, that sort of thing? And one of the great things about using an external database, you end up, an external Blobstore, you end up having all of that sort of features that come with. You know, it's up in an S3 bucket. You don't have to worry about it too much. And in terms of external storage costs, obviously, the internal one is the only one that doesn't incur external storage costs, unless you choose to store it externally. And then, as well, because there is storage of like actual physical copies of blobs, the GCS and the S3 incremental have the highest. And we also talked about how you can trade off the entirety of backing up your Blobstore with your recovery time. Cool. One more thing that we'll mention, just because we're here, there are a few things that we kind of have on our ideas for things. BOSH still has a very upfront, like brute force backing up of its Blobstore, so we're also thinking of how can we potentially selectively back up the BOSH Blobstore as well? Can we get that size down? We also want to be able to make it easier to switch between selective and full backups. So right now, doing a selective backup is something you choose at deploy time. And obviously, that's not ideal. It would be great if you could do it at a cadence, right? So maybe do a full backup once a week, selective backup daily, that sort of thing. And we also have something in the works where we want to be able to select, to have app developers back up their own service instances, specifically of the on-demand broker. Right. That's it.
Do you have any questions for us? So we'd like to bring you the microphone. Yeah. Okay, we can do that.
Hey, I'm Will from Engineer Better. I was just wondering, like I can see a really obvious value for BBR with particularly sort of customers that we've got, that's Snowflake app deployments a lot and things, and it's quite hard to recover unless you've got backup like that. But I was wondering, what would you say about the sort of minority of customers that we've got that have got really, really good automation for deployments, which you could use that to recover? What would you say about the value of BBR with that type of customer? Is it still like a much quicker recovery, or what would you say about it?
So this goes down the problem like recovery versus recreation. So if you have the necessary automation to do it, selective backups is one way to do it forward. So you just keep your Blobstore and you have your automated pipeline. So you just recover users, orgs, and spaces. That's some input that we had, and that was the main drive behind selective backups. So you can take backups frequently, and then you can repush everything because you have the pipelines to do it. But we cannot make the assumption that everybody has this nice sort of automation like in place. But ideally, that depends on your RTO, how fast you want to recover, and how flaky can be your staging of your apps. Because we think it's straightforward, but maybe like the whole staging process is not that straightforward, so you don't have to.
I mean, definitely, like you would. There are quite a few customers that will just go for recreation instead. But if you have like maybe in your company like auditing problems or specific requirements that require that you always have like copies of things. Another strategy as well is just to have multiple platforms. So you'll have multiple versions, BOSH directors in different locations and stuff, and then have that as your failsafe as well. Yeah.
The choice of not using GCP was that it doesn't have a cleaning strategy, or it doesn't have versioning, because that was not 100%.
Sorry, I ran through the slides because in terms of time, it was unnecessary. So the GCS has versioning features, but then if you tell people turn on versioning and they don't have a nice, straightforward way to clean up things afterwards, we don't want to recommend it because it doesn't have good lifecycle policies to remove deleted blobs. That was like the main problem. And then you could have to do it on your own, and that can potentially devalidate a backup you just took by removing a blob that you shouldn't. And then in recovery time, you find out it's too late.
Does labeling helps if you label the backups that get deleted?
Yeah, so we thought multiple things, and no solution was straightforward enough, and we didn't see like a great value. We didn't have like much input, so we wanted just to cover that for people who are using GCS. They can still take a backup; it just like takes longer. That's like the main thing. And and we're just waiting people to fix, because we gave this feedback to GCS folks. We talked with engineers from Google and say, fine, we'll do it. And we're probably, as soon as they do lifecycle policy properly, we just switch to versioning and then solved. Yeah.
Awesome, thank you.
Any other questions? Great, thank you.
Awesome.